So this is what we are doing. We try to connect the dots from UE, from RU. I think we present this figure in the beginning 4 years ago to the program office and the reviewer. At the last moment, we only have few modules. We get very good comment from the reviewers, so we try to build up everything. Originally, our focus is only OSC. This is OSC open source. But since we already work with OAI, so we also have OAI module. But during this past 4 years, we start to integrate with the commercial simulator, rain simulator, the UE simulator, RU simulator. We also work with the BRB for the rain simulator. Now we also work with some open source project, commercial project. For example, very important one is 35GC, Professor Cheng's team. This is also requested by the reviewer at the beginning of the project. They encourage us to co-work with another project. In addition to that, we also have some startup company. This is Capital Engineers from TU Dresden. This is commercial Aspura is a startup company from Professor TYSU. Then now we try to interconnect everything. So this is what we want to say thank you for the NSDC, for all the sponsor for this project. So briefly, here Linux Foundation networking. Now they keep lots of effort. They spend lots of time to have some white paper. They address that there are 5 key drivers for intelligent networking. In ITU, they also have a focus group for AI native network. So everybody knows that AI native network, they focus on automation, optimization, intelligence. From 5G to 6G, they start to shift from automation to autonomy. So AI used in the RAN normally is for prediction, control, and optimization. But the challenge everybody talking about the AI, talk about the AI RAN application. But the challenge is we need data. Everybody needs data. Another challenge is interoperability. When you want to have data, you need to have an end-to-end solution. So interoperability would be the key. Security is also a key challenge here. In OSC, we are also looking for talent working to solve the security issue for the open source. Here also we can find some different standard related for AML. This part is for 3GPP. From 3GPP, they define the architecture, define the use case. They also define the MWDA. This is a function to support AI function. The key, they also address the key use case, mobility, prediction, QoE, traffic routing, energy saving. So energy saving now is a common use case from 3GPP, from Orange Alliance. Orange Alliance is another standard. They actually is a compromise with the 3GPP standard. 3GPP standard focuses on RAN, but Orange Alliance want to increase its scope. So Orange Alliance already have some workshop co-work with 3GPP. Even since that is still a long way to go, but they have some new idea there. Basically, Orange Alliance try to define the architecture and API for AI in RAN. They have some AI/ML related working item in working 2, group 2, 3, and 11. Security is also one of the important issues for AI/ML. There are 4 important interfaces: A1, E2, O1, R1. AI Alliance define the usage case. Everybody know that they define AI and red, AI and red, AI for red. To summarize, 3GPP defined the global blueprint and the technical foundation, Orange Alliance. They try to provide open, multi-vendor environment. AI Red Alliance, they try to provide some new use case. Two main challenge, two main ingredients to enable intelligent AI Red. One is Intel-driven Red automation. Another one is SDK and the telecom API. This is quite important now, since everybody needs to have a common API to address data. So from open source project, what is a law of open source? Actually, some of the information is get from ChatGPT. So ChatGPT can give a very clear why we need to do this. First one is de facto test to implement for implementation and testing. And also, open source also can reach the standard and the deployment enable academia, industrial cooperation. I think this is what we learned from this project. So essential role in open source in AI, we have some issues here, but I just want to address some key open source project in telecom. The first one is our project get involved is OSC, Orange Software Community. Orange Software Community define the SMO, define the RIP, define the DU project, AI Mainframe Pro project. We also have an integration project to integrate everything. They also, under Linux Foundation, they also have ESA project. They define the SD core, SD RAN, smart 5G. ONET is used also in SMO to provide orchestration, management, and automation. Netfield is now widely considered in Orange Alliance, co-work with Orange Alliance to have all cloud, deploy all cloud. They provide a Kubernetes-based platform for network function orchestration. Another important one is Free5GC. This is open source, widely used core network in many universities. Another one is OAI. OAI is from Eurocom. Eurocom, they have RAN. They also have core network. They also have OAM. This is SMO RIP. They call it Fresh RIP. They also provide CI/CD to integrate everything. Now we also try to integrate with SRS RAN. SRS RAN provide 5G RAN, CU and DU. During the conference, actually I also met the chairman for AI Red Alliance. He just pointed out a very important project, ongoing project under Linux Foundation networking. They call it Akudu project. Akudu project is provided by, is raised by United States DoD. They want to seek open source software for 5G, 6G. The vision is they want to provide open source RAN for everybody. So this is very ambitious. Why? They want to have open source RAN with full end-to-end RAN stack. In addition to RAN, they also consider the management SMO RIP. They also want to use SF, RF, RIP to bring the AI function. So why? Because they said that AI for RAN, AI in RAN research and implementation, one of the fundamentals is OCU-DU. So this is also one of the project focus of our project. So this is the project scope. So if you are interested, you can search the OCU-DU project. You can see that this one. So they define hardware, software, and other parts management. So this is the from DoD budget estimate. So here you can see the from 23, 24, 25, they already reserved lots of funding. This value is in million USD. For open source, we just mentioned for RIG, for AML, for data collection, for physical, for RAN, we already have many open source projects there, especially in OSC. OSC have RIG, OAI also have Fresh RIG, Ether project have SD-RAN. AML framework in OSC, they have AML framework. Actually, in our project, Professor Luis also provide a new AML framework. They are also working with OSC. For data collection and analytics, OSC define SMO with RIG. OAI also have MVP. Physical layer, they have OAI. So the key here is OSC define important open interface to collect the data. So this is the project Orange Alliance. Here is the Orange Alliance standard. This is the project. This is the project leader. So this is AM framework. Now, when we actively work with the open source project, we found now they are trying to disaggregate the SMO. So they try to they always they are trying to change the architecture. So working with the open source, one of the benefits we can keep track to the most up-to-date standard. So the idea is here is SMO, here is non-real-time RIG, here is near real-time RIG. So the important open infrastructure is overlay. So AM framework, they provide all the automatic function to train the data, to deploy the data in here. OAM, they have RAN at the core. This is their SMO. This is their RIG. For Ether, this is their RAN. This is the SMO and RIG. SD-RAN, basically, they focus on the RAN and they focus on near real-time RIG. Challenge to support AI, in addition to lots of issues, I think talent and sustainability of open source projects is important. So we encourage student professor to join this part. I think this is quite important. Then we show you some of our results. This is from BRB. They want to have a RAN digital twin several years ago. Now we try to, so they have cyber RAN, physical RAN, then they can use SMO RIG. So we work with BRB, then we try to realize the common platform is quite important. So ongoing job, we try to do standard compliant interoperability test. Then we start to scaling from prototype to deployment. So we try to do configuration, integration, automation, test automation, deployment automation. So this is the common platform we are doing. We use all the project result from near real-time RIG. This is basically from Nokia. SMO and the non-real-time RIG. SMO is based on high street. Non-real-time RIG is basically Ericsson. AML framework is from Samsung. So first thing we did is, this is the new architecture. During the integration, we still need to change a lot of things. So this is SMO. So the basic idea for SMO is the service space architecture. They try to decouple everything, use common SMO communication to interconnect everything, such that everybody can collect the data directly. So this is our implementation. So we use open source project to interconnect with the BRB simulator. The purpose is to ensure A1, E2, O1 interface compliant with the standard. So this is a RAN. In BRB they call it RAN-text. This is a RAN simulator. With this background, so we are able to use the common SMO and rig. Now we start to connect to a real base station. The real base station now we are able to do is OAI base station. So OAI base station, so we connect it to commercial RU. So look, we use a configuration RF to configure base station and the RU. We also have integration RF to control the UE, control the handset, configure the base station. If you are interested in our demo, we will show this part, what we are doing here. Second one is test automation. We try to create SMO and rig plus the cyber rig. So we take the VRV simulator as a cyber rig. So we try to work with E3. E3 gives us a test document. We want to automate everything. Traditionally, everybody needs to configure everything in the simulator here. But now we use SMO and rig to automate everything. Use the configuration to configure the simulator. You use the configuration, use the configuration to control, even control. We use the open RESTful API, open API provided by VRV to control the simulator, such that when we have the test case, we can run all the tests, come out with the result automatically. Third one is deployment automation. We still use the SMO, but then we try to deploy it to an cloud, such that we can have physical and virtual. We can have physical CU. We also can have virtual CU. With virtual CU, we can increase the size to do large-scale deployment tests. So the idea here actually is similar to Bubble Rain. Bubble Rain is our partner. They want to have everything, SMO and rig, to control their software. So they are able to do simulation using their software. So, quick summary, open source is a cornerstone of AI rate and the security innovation. So, strong synergy with 3GPP and O-rate effort. So we hope to find some partner, even student or professor, to work together to build up the future together. So we hope to find more people to join, contribute and input with the open source, support test-based driven AI rate research. AI rate research now very popular. So we hope to use this opportunity to encourage everybody to support the test bed, work on the test bed together so we can do more things together. Next of all, we also want to announce Open Rain Summit. This is one of the programs under Global 2025 IFE program. We already appoint a keynote speaker. Originally, we tried to invite the new chairman of the Dutch Telecom, Abdul. But he's promoted, so he's quite busy now, so he will not be able to join us. Up to now, we have two keynote speakers. One is Dr. Yi Shi. She's the co-chair of ORAN GSC. Another one is Ed Tiedemann. He's SVP from Qualcomm. We also arranged 4 industrial panels. So the program is quite interesting. So hope you are able to join us. So we have Open RAN for operator. We also have open source lab. We also have from VRV also invite users to show us the status from International Big Lab. Last of all is from Tony Quay from Air Alliance. So thank you. Sorry for the delay.
Yeah, thank you. Now we have a few minutes for questions or comments. Oh, please.
use case based on the AI or AI open source rate in the future? Or is there any use case announced so far in the world?
Actually, since we already have the open source platform, actually we are working with NVIDIA. They try to use, they also need open source. They also want to build up an open source platform. So NVIDIA already have many tools, especially the LM model. They also have some AI agent. But they need to train the data. We just mentioned data is the key. So they need to have some real data from the brain. They try to work with operator, but operator did not disclose their data. So we try to use open source, for example, OAI as a reference to generate some data. For example, what we are doing now is we want to use LLM, try to debug. When we are doing integration, the big problem is we integrate everything, follow the standard, follow the document provided by the community, but in most of the case it doesn't work. Then it takes lots of time for debugging. Nobody knows what's the reason. So we are trying to do this. Yeah.
Okay. Any other question or comments? No? Okay, that's thanks, Professor.
Thank you.
Okay, now we have around 10 minutes break.